When it comes to science fiction militaries, one of the most iconic vehicles in a fictional arsenal is the tank. However, it can also be among the most complicated elements to get right when designing one for your own fictional setting. Today, we'll be covering how a tank protects itself in modern and future battlefields, talking about armor design as well as countermeasures that can be deployed in the far future. Most importantly, I'll be discussing why armor isn't as significant as people think, and why tanks usually rely on other methods of protecting themselves. One of the most important aspects of a general-purpose tank is how it balances the golden triangle of tank design: armor, firepower, and mobility. Next to a tank's armament, protection is one of the most essential elements of designing a vehicle. A lot of thought has to go into the armor layout of a vehicle, how it interplays with its mobility, and the countermeasures it employs. One of the most common misconceptions about tanks is the assumption that the armor itself is the biggest component of protecting a tank, and that therefore thicker is always better. This is not the case. In tank design, the armor itself is actually the last line of defense. It's there in case the other aspects of protection fail, but cannot be used as a crutch. This concept is called the Survivability Onion. There are many variations, but the basic principle is that you want your tank to avoid being hit in the first place. Except in cases of extreme technological or crew experience gaps, the tank that can accurately fire first wins, regardless of armor. As such, armor is only one of a plethora of tools modern tanks use to protect themselves. One of the most essential aspects of defending a tank is to avoid getting acquired by the enemy. At the ranges tanks fight at, even in the relatively close quarters engagements of the Second World War, simply pointing your gun in the direction of the other tank is rarely enough to score a hit. The gunner has to zero in on the target, determine an approximate range, and compensate for things like movement or drag. Tanks use a variety of tricks to make these tasks more difficult. For example, many tanks employ dazzlers and other electronic warfare countermeasures to interfere with an opponent's ability to zero in on a target. These are primarily designed to disrupt the rangefinders and guidance systems on incoming ATGMs, but some systems are capable of affecting the target acquisition on a tank as well. In the future, you could even see electronic warfare suites designed to hack the enemy's firing systems or even shut down the vehicle entirely. In this case, tanks might be integrated with battlefield AIs attempting to counteract these electronic attacks, while launching offenses of their own. Depending on your setting, there might be a lot of interesting countermeasures that future civilizations might come up with. Tanks also rely heavily on visually obscuring themselves from enemy detection. The simplest form of this is camouflage. While it might not look that effective at a glance, at standard engagement distances, it can make your tank just hard enough to spot that it can get that crucial first shot. Proper camouflage can also be extremely important for avoiding air attacks. Especially in a low-tech setting where pilots rely on optical spotting, it can make your tank much harder to see from above. In the far future setting, this camouflage could even be replaced by an active cloaking system, like the ones employed by the Covenant or Romulans. If these could be adapted for use on a tank, they could be extremely potent for planning ambushes or evading patrols. Even a more realistic application, such as in War Thunder's Warfare 2077 event, they would be invaluable for breaking up a vehicle's visual profile. In addition to camouflage, modern MBTs also use a variety of techniques and systems to mask their thermal and acoustic signatures. These limit the amount of heat and noise the tank, especially the engine, gives off, which can be especially important for evading detection at night. These measures also help against some guided ATGMs. While they are unlikely to trick more advanced systems, it can sometimes be enough to prevent a simpler one from maintaining a lock. Once combat has initiated, tanks also have a number of tools for concealing themselves and thereby preventing a target lock. The primary method is through the use of smoke grenades mounted on the turret. These smoke grenades can be used to break an enemy's visual contact and protect a tank from infrared guided missiles. Depending on the setup, these smoke grenades can be fired individually or in groups to create a blanket of concealment. Tanks have been using these since World War II, and they do not seem to be going away. In addition to these passive systems, modern tanks also employ a wide variety of countermeasures to deal with projectiles. One of the simplest forms of this is the explosive reactive armor, or ERA for short, developed in response to chemical effect rounds like the high explosive anti-tank, or HEAT warhead. These explosive plates detonate when they are hit by a penetrating projectile, using the two metal plates inside to disrupt the HEAT warhead jet penetrator and thereby decreasing penetration. Though most effective against chemical warheads, it can also affect a kinetic round by changing its angle of entry or even shattering the round entirely. However, I believe ERA would have very little effect on most energy weapons. After ERA plates, there are a number of advanced hard kill solutions for destroying incoming attacks. These systems, such as the Russian Arena system or Israel's Trophy system, work by detecting an incoming projectile and firing a countermeasure designed to destroy it, usually by prematurely setting off its warhead. This form of active protection system is extremely advanced and requires powerful ballistic computers in order to calculate the correct way to intercept the incoming projectile. As such, they are mostly effective against slow-moving ATGMs. In the future, it might be possible to use them to intercept normal tank shots, but it will require significantly better computers than we have now, and even then its effectiveness will be spotty. A tech-illiterate faction like the Empire or the Imperium definitely won't be able to make use of these. In a science fiction setting, another form of hard-to-kill system that is unavailable to the real world is shield generators. If a civilization can miniaturize the power supply and generator needed to create one, assuming it's possible in the first place, I think mounting energy shields on a tank is a fairly obvious choice. Actually, I'm not sure why more science fiction factions don't do this. The only examples I can think of are the Banished Wraiths in Halo Wars and the CIS super tanks in the Clone Wars. Though for many civilizations it is outside their technical capabilities, even factions that clearly have the ability choose not to for some reason, despite how significant a protection advantage it would provide. I am not saying here that every science fiction faction's tanks should have energy shields. For some, like the Imperium, it would simply be out of reach, and for others like the Covenant, it would have a negative effect on the audience's experience. All I am saying is that if your sci-fi civilization has the technology to create miniature deflector shields, but doesn't mount it on its vehicles, you should come up with a good reason why. Finally, after all of these other countermeasures are exhausted, we get to the actual armor of the tank. One of the biggest issues tanks face is balancing the amount of armor they have versus all of the other factors a tank needs to excel at. Simply having the thickest armor possible doesn't work because it comes with significant trade-offs. Thickening a tank's armor rapidly increases its weight. On top of how this affects its base mobility, this can significantly hamper a vehicle's operational and strategic mobility. For those of you unfamiliar with the term, strategic mobility refers to a unit's ability to reach an area of operations, and operational mobility refers to a unit's ability to reach a point of combat within an operation. While top speed is part of it, there are also a lot of other factors that cause problems for a heavier tank. Even if a tank has an engine capable of moving it quickly, it will still suffer because of rough terrain, ground pressure potentially damaging roads, and an inability to cross some bridges. On a strategic scale, the issues with a heavier tank become even more apparent. Increasing the weight of a tank beyond a certain amount makes it more difficult to transport across long distances. It limits the tank's own operational range, makes it more difficult to ship by rail or sea, and the factor especially important for an interstellar military, prevents it from being airdropped or air transported. All of these issues are really bad for a sci-fi military, especially one that has to operate on an interplanetary scale. It doesn't matter how well armored your vehicle is if your dropships and space marines can't get it to the front lines. Because of these issues, most countries focus on making their armor more effective rather than making it bigger, and they use a variety of tricks to do so. One of the most common methods is to use sloped armor. Depending on the angle of attack, this forces the projectile to travel through significantly more armor in order to actually penetrate the tank, as well as increasing the chances of a bounce. This means that a sloped armor plate will be more effective than its raw thickness might suggest, and that designers can allocate that saved weight to other components of the tank. Tanks will also use a technique called spaced armor to reduce penetration. With this method, multiple layers of armor are spaced apart in order to destabilize the projectile as well as prematurely detonate any explosives. This can be built inside the tank, but many vehicles mount a type of external spaced armor called Slat armor to fulfill the same purpose. Most tanks also reduce weight through how their armor coverage is designed. With a few exceptions, most tanks concentrate their armor towards the front, with some armor on the sides and very little armor on the back and top. This allows the designer to focus on where a tank is most likely to be hit, while limiting the amount of unnecessary mass added. However, it does mean that your tank will be quite vulnerable to ambushes from the side and top attack missiles. Real tank crews have learned to get around this through situational awareness, infantry support, and careful planning. So if the crews in your science fiction setting are well trained, they will do the same. It is guaranteed, however, that enemies will attempt to exploit this vulnerability in the armor, as they do in the real world. Even if a tank is the best vehicle possible given the technology, and even if its crew does everything right, sometimes it will get hit, and when it does, it will sometimes get penetrated. A tank crew is pretty valuable, and a good tank crew is nearly irreplaceable, so unless the faction's doctrine relies on cannon fodder, a tank designer needs to do their best to make sure the crew gets out alive. One of the biggest threats to a tank crewman is an ammo detonation. It doesn't take a genius to realize that if the ammo takes a hit, there is significant risk of it burning or exploding. There are a few ways to mitigate this, however. One simple method is to stow the ammunition in places that are less likely to get hit, such as on the floor of the vehicle. In the World War II Sherman, for example, a simple relocation of ammo racks from the side sponsons to the floor was enough to reduce burn rates from 60 to 80% to 15%. Another method of protecting the tank crew is blowout panels. When the ammunition is hit, these vent the explosion out of the side of the tank so the rest of the vehicle is safe. All of the ammunition is lost, but the tank can still get back to base intact. In a future tank, this could possibly even be done through shielding or something. In a sci-fi setting, tanks may also attempt to eliminate the risk of ammo detonation entirely through new weaponry such as the ETC gun or railgun, which I covered in a previous video. Aside from ammunition explosions, spalling is one of the most serious threats to the crew aside from the projectile itself. Spalling refers to the pieces of metal, usually fragments of the projectile and parts of the wall that are sent flying when a tank is penetrated. These can be launched with significant force and can easily injure or kill a crewman. Some warheads, such as HE or HESH rounds, can even cause it without actually penetrating the armor. Tanks use a few features to limit this spalling. First, modern tanks are usually equipped with spall liners, a thin layer of materials designed to catch these fragments before they can hit anyone. Second, tanks will try to separate the crew into multiple fighting compartments. This minimizes the chances that the entire crew gets taken out at once. With so many factors to consider when designing a tank's protection systems, we should probably quickly recap what we have learned in this video. First, there are a lot of things that go into protecting a tank, not just armor. Not getting hit is always a higher priority than not getting penetrated. Second, tanks will use a wide variety of countermeasures to conceal themselves and prevent being targeted. This includes things like dazzlers, camouflage, smoke grenades, and in the future, electronic warfare or even cloaking devices. Third, many tanks use reactive armor to reduce penetration or even active protection systems to destroy incoming projectiles. In the far future, tanks might even be fitted with energy shields or other technologies to protect themselves. Fourth, designers have to be very careful about designing the armor itself. Though thick armor can help a tank's survivability, it can also limit a tank's strategic mobility and its ability to be transported by dropship. A good designer will use tricks like sloped armor to make the tank more effective without making it heavier. Finally, a tank also has to protect its crew in case of penetration. The biggest threats to a tank are ammunition detonations and spalling, but these can be mitigated through things like blow-up panels, spall liners, or using futuristic ammunition that won't explode when hit. With all of this in mind, I think you should be well equipped to write about your own sci-fi tank's armor and protection systems. In my next video, I'll be rounding off this discussion about sci-fi tanks by covering mobility and logistics. Until then, however, I will see you all Starside. Thanks for tuning in to this episode of Starside. If you have another topic you want me to cover, make sure to comment down below and it may just become my next video. If you're interested in more, make sure to hit like and subscribe. Anyway, have a great rest of your day.